If we suddenly lost the moon tomorrow, what would happen? Scientists have some fascinating and a few downright terrifying theories. Changes between winter, spring, summer, and autumn occur every year, so it's easy to take them for granted without ever thinking about why they happen. These all-important seasonal changes are the result of the tilt of the Earth as it revolves around the Sun. On average, Earth tilts 23.5 degrees, which means the poles never face the Sun directly head-on. That would be disastrous. But while it's easy to assume the Sun is the big factor when it comes to Earth's seasons, none of it would be possible without the Moon. In fact, scientists believe the impact between the Moon and Earth is what gave our planet its 23.5-degree lean. What's more, the gravitational pull between the Moon and Earth helps stabilize the tilt and prevents the planet from tipping over and pointing the North Pole at the Sun. Without the stabilizing factor of the Moon, we'd likely see weather chaos, and when it comes to the seasons, they'd be completely unpredictable. Aside from seasonal changes that influence the amount of daylight you get during certain times of the year, it's also possible that without the moon, our days would all be shorter.
During the day, there will be a limited time to metabolize and gain energy and do things. Organisms would have to be a little more clever.
There are two major factors that impact the daylight hours here on Earth: the way the planet orbits around the Sun, as well as your specific latitude. On average, Earth spins on its axis one time every 24 hours as it makes its journey around the Sun, but the rate of that spin used to be much faster. Thanks to the moon, it's slowed down significantly. In fact, scientists believe the moon relies on Earth for its spin energy, which in turn decreases the rates of speed for both. The moon also continues to move away from the Earth 2 inches per year, which can slow down the spins even further. It's estimated that the average day on Earth was only 6 hours long until the moon began slowing down the planet's rotational speed about 4.5 billion years ago. For comparison, scientists believe that 650 million years ago, the average day was 22 hours long. And if you're wondering if days will get longer or shorter going forward, here's your answer. Our days are still gradually getting longer due to the gravitational pull between Earth and the moon. The ocean's tides are dictated by both the sun and the moon, but the moon is the greatest influence due to its close proximity to the Earth. The sun is 390 times further away. While the moon isn't the only entity that affects ocean tides, it plays a major role in creating high and low tide cycles because of its gravitational relationship to our planet.
The moon kind of pulls the Earth's water towards it.
With each gravitational tug, Earth subtly elongates around the equator, which then creates ocean tides. At the same time, the Earth continues its normal rotation. These two occurrences contribute to the two high tide and low tide cycles you see along an ocean shore each day. Needless to say, without our moon, these tidal patterns could cease to exist. High tide cycles would no longer result from the elongation of the Earth due to the moon's slight pull. And overall, tidal patterns would be much less distinct, an estimated third of their size today. Without these high tide cycles, water couldn't churn in Earth's oceans, which in turn might disrupt the life cycles of a variety of marine animals, including mussels and crabs. Ecosystem disruptions could, and probably would, lead to extinctions. What's more, ocean tides help push warmer waters around the globe. Without the moon, this could stop, adversely affecting Earth's climate. Without the stabilizing effects of the moon, Earth could experience drastic climate changes, including extreme cold and heat at each of the poles. Once again, this all comes down to the gravitational pull of the moon. Scientists believe the moon acts as a climate stabilizer because it helps the Earth move smoothly and consistently. Without the moon's influence, the planet could wobble around with no clear rotational patterns. While it's difficult to predict exactly what Earth's climate might look like without a moon, it's worth looking at one of the planets in our solar system that don't have moons for comparison: Venus. Venus is the hottest planet, and there's no difference between night and day on its surface.
I didn't know this was a moving picture studio.
You're a bit confused. This is the planet Venus.
The average surface temperature measures at 869 degrees Fahrenheit due to its close proximity to the sun and its inability to tilt more than 3 degrees at a time. Given how far Earth is from Venus, it's hard to say whether, if Venus did have a moon, it would make a significant difference to its climate. But it's interesting to think about. While humans might technically survive without a moon, some species might not be so lucky. Nocturnal predators would likely be the most impacted. These include animals who rely on moonlight to help them hunt at night, as well as animals with good night vision, such as wolves and owls. An inability to see and find food or to hide in the dark while stalking their prey could lead to devastating extinctions for some of these predators.
Sharks would lose their hunting prowess, unable to track the schools of fish swarming above them in the moonlight.
In turn, the natural ecosystem would change due to an overpopulation of prey. Aside from the light of the moon, certain species have evolved to be dependent on the moon cycles for other biological necessities. Salmon migration patterns are one example. While salmon migrate to the ocean under the dark cover of a new moon, they wait upstream in rivers during a full moon. In theory, if the moon disappeared, this would cause confusion among salmon, who might not ever stay in rivers. This would cause disruptions in the population and adversely affect animals that fish for them. A lack of a moon could also spell trouble for several ocean species who rely on the light of a full moon for reproduction. These include coral, mussels, and some varieties of fish.